Good morning, class. Welcome to another learning session in pre-calculus. For today, we will be discussing about conic sections. What are these conic sections? And what are their applications in real life? Well, let's find out the answers after going through this presentation. Ito po ang inyong lingkod ng bayan, in service to the Filipino people. Ako po si Mr. June Mark Reynob, teacher na nagmula pa sa El Salvador City Division. Are you ready, class? Tara na, at sabay-sabay tayong matuto. Before we discuss conic sections, let us have a quick review about the basic concepts that we learned in the junior high school. Now, these concepts will help us better understand conic sections in a form of activity. So for activity number 1, we are tasked to match the following items in A to B. So in A, we have here the mathematical representation of a concept, and B, we have here the concepts being represented. Now we can answer this one right away, but we wish to visualize or graph each item in the GeoGebra. So for number 1, we have x squared plus y squared is equal to 9. So let's graph this one in the GeoGebra. We have x squared plus y squared equals 9. So here we have actually a circle. So obviously number 1 belongs to circle. And please recall that the standard form of an equation of a circle is the quantity x minus h squared plus the quantity y minus k squared is equal to r squared, where our center is at the coordinates hk and our r is actually the radius of the circle. Now number 2, we have y is equal to 4 times the quantity x squared minus 1. So we have y equals 4 times the quantity x squared minus 1. So we have here parabola that opens upward. So for number 2, we have here parabola. Number 3, we have the coordinates 0, 0. So we can hide this one for the meantime. So we have 0, 0. So we have actually a point on the origin. So number 3 is actually a point. Now number 4, we have here y equals 3x minus 2. Y equals 3x minus 2. So we have here actually a line. So number 4 is line. Recall that line can be written in the form y equals mx plus b, where of course our m is the slope of the line and b is the y-intercept. Now number 5, so y equals 5x minus 2. So obviously this is also a line. Y equals 5x minus 2. And we also have another line, y equals negative 3x plus 4. Y equals negative 3x plus 4. Alright, so we have here intersecting lines whose intersection is at the point or the coordinates 0.75 and 1.75. So number 5, these are actually intersecting lines. Now, did you know, class, that intersecting lines together with circles, lines, parabolas, and points are actually part of a particular class of curves called conic sections? That is actually what we will be doing for today. So we will be illustrating the different types of conic sections. Aside from parabola, we also have ellipse, circles, hyperbola, and we also have degenerate conics. So what is this conic section? This is a particular class of curves which oftentimes appear in nature and which have applications in other fields. Now the discovery of conic section is actually attributed to Menachmus, who is actually an ancient Greek mathematician, geometer, and philosopher, who is actually a friend to Plato, who is very known for being able to discover the conic sections. So this time we will be illustrating the different conic sections such as circles. We'll go to ellipse, parabola, hyperbola. So we will be illustrating these four common conic sections. And lastly, we will also be illustrating the degenerate conics such as point, line, and intersecting lines. So we'll be using GeoGebra. Now, the conic sections are actually called such because these are sections of cones formed when it is being intersected with a plane. So we need to have two cones in particular. So we have two inverted cones on the XYZ plane, XYZ axis, and we also have plane right here. Right. So we can actually introduce a point on a plane. Now, the plane can have many orientations. The plane can be horizontal, it can be tilted and intersect only one cone. It can also be tilted this way to intersect also one cone. It can also be tilted and intersect two cones. Right. So depending on the orientation of the plane would also be the conic section being formed. Alright, so let us determine them one by one. Alright, so let us establish the intersection of the plane and the cone using these broken curves right here. So notice that when the plane is horizontal, the conic section form is actually a circle. Alright, circle. So a circle is formed when the plane is horizontal. Now, when the plane is tilted or slant and intersect only one cone and form bounded curve, this one is an ellipse. So an ellipse is formed when the plane is tilted and intersect only one cone to form bounded curve. Now, when the plane is tilted in such a way that it will intersect one cone, forming an bounded curve. This one, unbounded curve. So this is parabola. So a parabola is formed when the plane is tilted and intersect one cone to form unbounded curve. Now when the plane is tilted and intersect two cones and form two unbounded curves, we have here hyperbola. So a hyperbola is formed when the plane is tilted or slant and intersect two cones to form two unbounded curves. So those are actually the common types of conic sections. Now, what about the degenerate conics? Now, if the plane is vertical, we can actually form intersecting lines such as this one. Right. So let us establish different points as well. So if we have this orientation, then we can also come up with intersecting lines. So if we have this one, so we can have line, one line on. So we can have line. Now what about a point? When can we form a point? So basically, okay, so a point is formed when we have our plane right here, no? Horizontal also. So what we have right here is actually a point. So now we have illustrated how to form the different conic sections. We're done illustrating circles, ellipse, parabola, hyperbola, and the degenerate conics. So let us have here an activity just to refresh, no, or to test our understanding with the presentation. So our task is to identify what type of conic section is being illustrated per item. So for number 1, when the horizontal plane intersects the cone. Okay, so we can actually visualize this one once again. When the plane is horizontal and intersect one cone, we can actually form circle. So for number 1, we have here circle. For number 2, tilted plane intersect one cone to form unbounded curve. So when the plane is tilted and intersect one cone to form unbounded curve. So what do we have here? We have here parabola. Okay, so number 2 is parabola. So we have here parabola. Number 3, the tilted plane intersects one cone to form bounded curve. So when the plane is tilted and intersect one cone only to form bounded curve, so how do we call this one? We call this one ellipse. Okay, for number 3, we have here ellipse. Now, number 4, the plane not necessarily vertical intersects both cones to form two unbounded curves. So when the plane is tilted, intersecting two cones, not necessarily vertical, we can actually form what we call hyperbola. So number 4, our answer to this is what happened? So this number 4 is actually so we can actually erase this one. So number 4 is actually hyperbola. Alright. Now we have illustrated how different conic sections are formed. Now what about the applications of conic sections? Are they really important? Alright. So I will be presenting to you the applications of conic sections. These are just some of the many applications of conic sections. Now, did you know that cooling towers in any industrial plant is designed as hyperbola, such as this one? Now, there are also designs, architectural design based on conic sections. We have one tourist spot in France, designed using parabola that opens downward. The designs of Ferris wheel are actually based on circles. We also have here an ellipse-inspired architectural design. Did you know that hyperbolas are used in combat, in sound ranging, to locate the position of enemy by detecting the sound of gunfire? Did you know that the moon's orbit around Earth is in the shape of an ellipse according to NASA? Did you know that the cables that act as suspension on the Golden Gate Bridge are parabolas? What about the wheels of cars? They are designed as circles, which is actually one of the conic sections. So those are just some of the many applications of conic sections. Perhaps I will be leaving you with this activity. You must research on the other real-life applications of conic sections. Alright, so that is all for today. I hope you learned something out from this very simple presentation, not just on illustrating the different conic sections, but also in determining its applications in real life. So once again, ito po ang inyong lingkod ng bayan in service to the Filipino people. Ako po si Mr. June Mark Rinob mula sa El Salvador City Division, saying God bless sa inyong lahat. Thank you for watching. Keep safe.